entered into the cylinder, what happened at that time? From the Lemmy equation, we know stress R is B by R square minus A. This is the formula. So we will be taken up the case when R1 value is given to us, and we will be taken the case for this value R2. For this case, R1 will be 0, stress R1, the radial stress will be 0. Why? Because no fluid has been entered into the thick shell. So second will be the R2, whose value is already given to us, that is 12 megapascal. So we will having two equations now and two unknown terms. Shubham, are you able to understand? Two constants, that is A and B, and two stresses. Stress R1 is 0 because fluid has not been entered. Stress R2 value is given to us, that is 12 megapascal. We calculate the value of A and B, which is coming out to be this. We put this value into the circumferential stress, because in the question we desired what is the desirement, what is the requirement of the question, then what is the final stresses which are being generated in the cylinder. So we have calculated before entering the fluid circumferential stress in this portion and in this portion. So which is coming out to be 54.82 and 42.82 compressive. Why it is compressive? Because this third assembly is exerting the pressure onto this part and this part. So that is why it is necessary that it will come to compressive. Now coming to the outer tube. On the outer tube we are having two radius, that is R2 and R3. For this similarly we will apply the Lemmy equation. Stress R is B by R square minus A. Now R2 will be 0.120, R3 will be 0.150. We will similarly calculate B dash and A dash, and from that we will further calculate the circumferential stress in this region and in this region. Earlier we have calculated in this region and in this region. Now we have total 4 circumferential stresses. So this one is the circumferential stress 2, circumferential stress 3. So these are two coming out to be tensile. Okay. So this step 1 and step 2 is total complete now. Coming up to the step 3, which is when the fluid is entered into the cylinder. What happened at that time? You have to take only two cases, two radius at that time. That is the internal radius R1 and the external radius R3. We will be not considering R2 now, because fluid has been entered. We will be dealing up with the internal pressure. Internal pressure is given to be 90 megapascal. This 90 megapascal is put as a radial stress. Radius is given at that time, put into the Lemmy equation. We get two values are unknown, B and A. Similarly, on the outer shell, radius, what will be the value of the radial stress? What will be the value? 0. Why 0? Because at the outer end, the radial stress has to be 0, because at that time if the radial stress is not 0, it will burst up. Okay? Because we have assumed that it is isentropic section we have already taken. So stress 3 0 at R3. We have put the values in the Lemmy equation, so get B and A as constant. So on solving that, we find the values of A and B, which is coming out to be this. We put these two values in stress, circumferential stress, to calculate in when fluid has been entered. At this end, at this end, at this end. What is the value of circumferential stresses? These three values. These are the values of the circumferential stress which we have written already. Okay, this one 191, 129.71, this one and this one. Okay, now you have calculated total 7 circumferential stresses. How you have calculated 7? Before entering the fluid, one circumferential stress over here, one over here, one over here. Okay. Second time, when you have calculated the circumferential stress, because 2 was common at both parts when you take before entering the fluid, so stress C2 will come 2 times, one for compressive, one for tensile. So now in the case of outer, you will be having 3 stresses only, here, here and here. So I have calculated stress C1, stress C2 and stress C3. So I have put all these values due to the fluid pressure. This is without the fluid pressure. I have added these values Okay, and this is my final result of the circumferential stresses. Circumferential stresses, which is desired in the question that you need to calculate the final circumferential stresses. So basically, in this question, you need to calculate the effect of the circumferential stress on a thick compound cylinder. So I guess this full case is clear to all of you. In this case, just keep one thing in your mind, that when the fluid has not been entered, then stress R will be 0 initially, and outer end, whether it's 3, 4, whatsoever be, that also will be 0. Radial stress at first point and radial stress at last point will be 0. When fluid has been entered, keep this thing in mind, that internal pressure has to be some value, that was 90 megapascal in this case, and for your stress 3, that is the outer, will be always 0. You will not be taking stress 2 in the case when fluid has been entered into the cylinder. So clear to everyone? This was all about the compound cylinder. Any query related to this? Okay, thank you.